Hello, welcome to Science is Your World. I'm Peter Shacklock, and the host of this show. It gives me great pleasure to introduce our guest, and he's Dr. Dan Thirumurthi. And Dr. Thirumurthi is a professor at the Technical University of Nova Scotia in the Civil Engineering Department. And what we're going to have Dr. Thirumurthi talk about today is something that we're all contributing to every day, and that is sewage. And Dr. Thirumurthi's research deals with the treatment of sewage leachate as well as landfill leachate. So first of all, Dr. Thirumurthi, welcome to the show.
Thank you.
Okay. I understand you're going to present this like a lecture.
Yes.
So maybe I should just let you take over from here.
Okay.
Yeah.
Most Canadians will agree with me that we would like to keep our rivers, lakes, estuaries, and coastal waters as pure and clean as possible. When we discharge industrial waste, raw municipal sewage, or partly treated sewage or industrial waste, the receiving waters get polluted, and that has adverse effects on fish life. The waters are not aesthetically pleasing. We cannot use the rivers and lakes for recreational purposes, and the water cannot be used for downstream purposes like navigation or human consumption or even for industrial use. So it becomes an important responsibility of the engineers to treat the sewage and then discharge the effluent of acceptable quality so that it will have minimum or very little negative impact on the receiving water.
So it's the treatment of the sewage we're going to be talking about.
Yes. So we are going to focus on treatment of sewage and what are the problems faced by the engineers to design and maintain those sewage treatment plants so that we can minimize water pollution. So my presentation today is going to be based on a series of figures and sketches, and we will start with the first one. One of the challenges we face while designing the system is that the amount of sewage or the municipal wastewater that reaches the treatment plant fluctuates from hour to hour and from day to day. So as a result, it's very difficult for us to design a system because the amount coming in is not a constant. It's fluctuating all the time from month to month, from year to year. There is a quantitative fluctuation as well as qualitative fluctuation there. So we have to have enough storage capacity in the plant so that we can design a cost-effective, optimum sewage treatment plant. So let us look at the solids content. When we take a sample of sewage and dry it, we have the total solids. That's also called residue after evaporation. Those solids have various components. One is the settlable and colloidal solids. The other one is the dissolved solids there. And among those, you have a volatile component and the fixed component. So approximately the volatile component is the organic portion. For example, proteins, fatty materials, and carbohydrate. Those constitute the volatile portion or organic. The remaining portion is called fixed or mineral or ash. Those are primarily inorganic in nature. So the sewage treatment plant has to be designed to focus on both those components there. Among the volatile organic matter in the municipal wastewater, majority of them are biodegradable. Of course, we have small concentration of toxic chemicals. Unfortunately, most of the treatment plants are not designed to remove those toxic chemicals there. Among the minerals, you have calcium, iron, sodium, inorganic phosphate, inorganic nitrogen. All these components are there, you see. So engineer has a challenge to look after both the components there. For example, when we look at the various properties of municipal wastewater, one of the criteria we have to look at is the pH of the water. The neutral water has a pH of 7. That is neither acidic nor alkaline. If you take sulfuric acid, it has a pH of 0. Lemon juice has a pH of 1. Orange juice has a pH of 3. Milk around 6. Whereas if you take caustic soda, it has a pH of 14. So acidic waters have a low pH and alkaline waters have high pH there. So in connection with acid precipitation, when the rainwater has a pH below about 5.7, that is called acidic precipitation. Whereas in the case of water, the neutral water has a pH of 7. And
do you try and adjust it to higher?
Yes. For example, if you want to remove the inorganic phosphates which create eutrophication problems in lakes because of excessive amounts of growth of algae, we want to remove the phosphate or PO4, and the most economical method to do is the chemical precipitation. For that we add lime into the wastewater and increase the pH to about 9.5 or 10, and then knock down the phosphate to the bottom of the tank, you see. There are so many plants in Ontario which use this method. They used this in the 70s and in the early 80s. But now engineers and scientists have developed biological nutrient removal techniques which are more economical. And whereas the chemical method has a high operation and maintenance cost, the cost of lime, the biological method is less expensive.
It takes longer?
Yes, the biological method takes longer. So we have to build bigger tanks.
More retention.
More retention tank.
Yeah.
That is called biological nutrient removal. That method has been developed during the last 5 or 6 years. So we don't have all the answers yet, but there are a good number of plants in states and a couple of them in British Columbia which are using the new technique. Most of us are familiar with the nitrogen cycle. So if you take the nitrogenous organic matter in presence of oxygen, it is aerobically decomposed into ammonia. Of course, that can take place aerobically as well as anaerobically, and that is called ammonification. After that, ammonia is oxidized to nitrite. That can take place only in the presence of oxygen. That is called nitrification. And nitrite becomes NO3, which is nitrate. So from ammonia to nitrate, it is called nitrification. Municipal sewage is a high concentration of organic matter and ammonia, and in biological treatment plants, that is converted into nitrate. Later on, it is denitrified from nitrate into nitrogen gas, and that escapes into the atmosphere. And nitrogen gas being inert, it has relatively very little negative impact on the environment.
I didn't realize that.
So if we want to remove the nitrogen from the wastewater and to save the receiving waters from eutrophication or biological oxygen demand, the best method is to go for nitrification and then denitrification. So for that we have to understand the nitrogen cycle there. Of course, we all know that nitrate is consumed by algae and other plant life. Plants are consumed by animals. The animal protein, when the animals die off, the microorganisms decompose the animal proteins, resulting in ammonia. So that is how the nitrogen cycle is completed.
Cycle.
And in the sewage treatment plant, a part of the cycle takes place. So in the next illustration, we have some idea about pollution of the rivers and lakes as a result of carelessness of man in looking after the receiving water. Whereas a clean stream, which is properly maintained, can be enjoyed by the people for recreation, boating, fishing, so on and so forth. For achieving that goal, the government of Canada as well as government of Nova Scotia have water quality standards. What is the minimum amount of oxygen that should be maintained in the stream so that fish and other desirable aquatic species can live in the system there. So when we design these sewage treatment plants, we use guidelines or manuals which are prepared by government agencies, and we follow them in order to design the most cost-effective sewage treatment plant. I was talking to you about the problems caused by the excess amounts of inorganic nutrients, namely nitrogen and phosphorus. If these excess concentrations are discharged into the lakes and rivers, we can have uncontrolled amounts of algal growth, and nobody likes to have high concentrations of floating algae forming a scum on lakes. So the property values in the neighboring areas will go down. When this water is used for human consumption, there will be unpleasant taste and odor. In the water treatment plant, the filters will get clogged, and obviously the water cannot be used for recreational purposes. It is extraordinary. Some of the lakes have been so badly polluted in North America. As a result of that, there is an abundance of algal growth. Of course, in Nova Scotia, we are fortunate to have a low concentration of people or low density of population. As a result, our pollution problems are not as serious as they are in other parts of the world. So this illustration shows an example of an extreme case of what can happen when man discharges uncontrolled amounts of inorganic nutrients, that is nitrogen and phosphorus, into lakes.
It looks like the stream's almost plugged or dammed.
Yes, yeah. So this illustration is an extreme case to emphasize the point about the adverse effects of excessive nutrients. Of course, in nature, there is a delicate balance between the nutrients, microorganisms, fish, and human uses. As a result, there is a very sensitive balance there. When excessive concentrations of pollutants are discharged, then that sensitive balance is disturbed, you see.
Yeah, these plants are using nitrogen and phosphorus, but yet we're getting too much of that.
Yes, yeah.
So we have
too much is going from the surface runoff, from sewage treatment plants, sometimes fertilizers from agricultural land, even from our home lawns, so on and so forth. You see.
Right. So can we actually get that out of the sewage? Can we get the nitrogen? You mentioned outgassing of that.
Yes.
So.
Nitrogen can be removed biologically. The first step is nitrification, and the second step is denitrification. That is the most common method to remove the nitrogen. Whereas phosphorus, which is a second nutrient, which is actually more critical than nitrogen, can be removed either by chemical precipitation or by biological means, where microorganisms take up the phosphorus and retain them as within their biomass.
So you're actually taking out the sludge?
Yes, yes. Yes.
Something you can handle.
So the phosphate is part of the biomass. It can be used as a fertilizer on land. So we call that as land utilization of biosolids.
And then the cycle starts again.
The cycle starts again, yes.
Yeah. Okay, so we can prevent this plugging up of the streams and lakes.
Yes, it can be prevented. Yes, it can be prevented. Yes.
This is,
yes.
yeah.
We have achieved it successfully in various parts of North America now, but of course we have a long way to go to reach our ideal targets.
Yeah. Okay.
I mentioned about dissolved oxygen in the rivers and lakes. Depending on the type of species we want to protect, whether it is a lake trout or lobsters, depending on what is the biological species we want to protect in the lakes and rivers, we have to maintain a minimum amount of dissolved oxygen in the rivers and lakes. You can express dissolved oxygen as milligram per liter or as percent saturation. Biologists will say sometimes that for certain fish species to live, you have to have minimum, say, 40% saturation or 60% saturation or 70% saturation. But engineers tend to look at it in terms of milligrams per liter. So when I design or when I train my students to design sewage treatment plants, I will tell them, well, let us have a minimum target of, say, 6 milligram per liter. See? Engineers go by numbers and biologists go by percent saturation.
Yeah, I think I can understand both ways. I think the animals have got to get the oxygen out of the water, and if there's only a certain percent there, they can only take a little bit of a certain percentage.
Yes.
But if it depends on temperature and other conditions,
yes,
like the number of milligrams might not be enough in a certain condition.
Right.
So
yeah.
I can understand both situations.
I see. Yes.
Yeah.
Ideally, most biologists will agree with me that in the receiving waters, we want to have low concentrations of a variety of organisms living there in nature, in balance. So if you look at this illustration here, on the left-hand side, in the y-axis, we are showing the variety of species. On the other side, on the right-hand side, y-axis, we are showing the population density. And in the horizontal axis, or x-axis, we are showing the length of the river. So the first 25% shows before pollution. That is clean water. When we have clean water, we have low concentrations of various species, but various varieties, the way Mother Nature created the environment.
A lot of different things.
A lot of different things.
Yeah. Okay.
Now, when sewage is discharged, some of the susceptible organisms die off, and some of the aggressive ones, tough ones, they can survive. As a result, we have lower varieties, but that is not the way in which biologists would like to have their rivers and lakes. So that is one of the way of measuring the pollution, as a result of which the variety goes down, but the population of a single species or less number of species dominate, which is not the ideal way. Nature also has the ability to assimilate and digest the pollution. So as long as the amount of sewage going in is below a certain limit, the river can assimilate and it can recover from pollution. That is called recovery zone. And then once the river has recovered, then we have the clean water again. Of course, unfortunately, in so many of the rivers now, the amount of sewage going in is so high and the concentration is so much that the rivers are not able to recover.
We're talking sewage now, we're not talking about chemical pollutants?
This is true for all biodegradable organic waste. The waste could be from municipal sewage, could be from leachate, for example, or it could be from a petroleum refinery.
Yeah, I suppose if it was toxic, it would never recover.
Yes,
so
right.
It would recover.
Yes, that's a very interesting point. We are focusing on biodegradable organic matter. Yes. If it is a highly toxic waste, then most of the microorganisms and most of the species are destroyed, and the river may never recover.
Yeah.
Yes, that's an excellent point.
Right
yes.
to the ocean.
Yes, yeah.
Okay.
So when we treat the municipal sewage, in the beginning we have what is known as pre-treatment or preliminary treatment, in which there is a screen to remove the coarse solids, and the grit particles are removed. Grit is coarse sand and fine gravel, broken glass, eggshells. All these inorganic solids have a tendency to create wear and tear, so that is called preliminary treatment. Once that is completed, then we go in for primary treatment, in which the settlable organic compounds are removed. They go to the bottom of the tank, and that liquid is called primary sludge. So in the illustration we have, it shows in the lower half of the diagram a typical clarifier or a settling tank. That settling tank could be either rectangular in shape or it could be circular in shape. The one we are looking at now is a circular clarifier, where the settlable organic solids go to the bottom, and then that liquid is called primary sludge. Now that sludge has to be digested or fermented, and that is accomplished by sludge digesters.
That's still primary treatment.
That is still primary treatment. Okay. Yes, yeah, primary treatment. In our metro area, Milco has sludge digesters. Eastern Passage has sludge digesters. Lakeside and Timberley have their own sludge digesters too. These digested sludge solids are taken to a lagoon in the airport. Personally, I would like to see that these valuable biosolids are used on land for agricultural purposes. Of course, agricultural land is so far away from Metro Halifax area, so there is a high cost of transportation. But in small communities where land is available within short distance, it is economically and ecologically more attractive to use these biosolids on land. And this is done very commonly in Ontario in small communities. But big cities like Toronto and Halifax, it may not be economically feasible to haul the biosolids long distances.
What would happen if you put this sludge in forests?
Yes, the digested sludge can also be disposed of on forest lands for growing Christmas trees, for example. This can be done. Yes. This is done in various parts of the world. Somehow in Nova Scotia it has not gained momentum. There are some communities like New Glasgow, Antigonish, which tried land utilization, but it doesn't seem to be economically attractive for Halifax.
A little too far away.
Too far away from the farming communities. After we have removed the settlable organic solids, we go in for the second stage, which is called secondary process. That is called secondary treatment or biological treatment. This can be accomplished by various methods. One of them is called trickling filter, where you have a solid medium or you have a plastic medium through which the wastewater trickles. When that happens, microorganisms grow on the top surface of the stone or plastic medium. In the 1960s and early 70s, we used gravel as the medium to grow the microorganisms. But beginning in the mid-70s, chemical companies have come up with a plastic medium. The plastic media can be used for the same purpose. Those are called bio-towers. And we have one in Port Hawkesbury, which uses a bio-tower. We used to have one in Eastern Passage, which had a bio-tower. But when the Eastern Passage plant was expanded, they went from secondary to primary, and now they have only primary treatment and anaerobic digestion of sludge. We do have a stone medium trickling filter in a school in Hammonds Plains, and there are a couple of native reserves near Truro which also use stone medium trickling filters.
How long would the sewage have to stay in contact with this? I mean, what's the retention time?
Few minutes. It takes only few minutes there, because the wastewater goes down the medium by gravity. The stone medium filters are about 6 feet deep, whereas the plastic medium filters could be even 20 feet deep. They have more porosity, more space, so they can handle deeper filters, and still they can maintain what are known as aerobic conditions.
So this is where the bacteria converts, is it converting the phosphorus and nitrogen?
Yes, the microorganisms use the biodegradable organic matter as well as nitrogen and phosphorus as a source of food, and they grow and multiply. So the biological film will become thicker and thicker, and they will get sloughed off, and that is called a biological floc, and that is taken over to the secondary clarifier, and they are settled by gravity. So the biological treatment can be achieved by at least 3 different methods. One of them is trickling filter or bio tower, which is what we have on the illustration there. We will come back to the biological treatment later on. I was talking in the beginning about preliminary treatment, that is to remove the coarse solids. In developing countries, these are operated manually. Screens are cleaned several times a day to remove the screenings. The solids are removed from the screenings, from the screen chamber manually. Of course, in developed countries and also in bigger cities, the cost of labor is so high. So during the last 30 years or so, we have been using mechanically cleaned screens to remove coarse solids.
Well, Dr. Thirumurthi, we only have approximately 1 minute left on this. Maybe we'll have to come back and do another show next week. But do you just want to sort of sum up where we are at this point, what we've discussed so far tonight?
Yes, yeah.
Okay.
We have discussed about the adverse effects of pollution on rivers and lakes, and we have talked about the highlights of primary and secondary treatment, mostly for municipal sewage, and what are all the advantages of controlling the pollution.
Okay, and next week we'll do another show probably on more sewage treatment facilities?
Yes, we can continue on the highlights which we have touched on today.
Okay, that would be good. I'd like to thank you for watching Science is Your World, and our guest today has been Dr. Dan Thirumurthi, and he's from the Technical University of Nova Scotia, where he's a professor there with the Civil Engineering Department. I'd like to thank you for watching, and stay tuned next week.